needs immediate attention. An interrupt alerts the processor to a high priority condition requiring the interruption of current code the processor is executing. When the high priority task is completed, lower priority tasks will continue to be completed. Processes and threads. A process is an executable program, data loaded into memory. A heavyweight process is also called a task. A parent process may spawn additional child processes called threads. Most processors are multi-threaded and will continue to execute those threads in the order unless something else, takes them out of sequence. Most people do not notice any interrupts in the threads because of the operating system scheduler of more modern operating systems. These excuse me. Most more modern tasks are open to multi-threading scheduling, since most modern programming and compilers take advantage of it. Most processors nowadays have more than one CPU. It can run multiple programs. Some of the higher end CPUs now can have up to 36 threads, like a AMD Ryzen can run 32 simultaneous threads. So most users, especially on Windows or a GUI-based operating system, it's multi-programming. So the multi-processing and multi-threading makes it pretty much seamless to users. Nowadays, there's different multi-memory protection schemes. Like Linux and GCC will now use application randomization, so the kernel will use randomized memory. So it's not the same every time. As a memory protection scheme, prevents the one process from affecting the confidentiality or integrity or availability of another, used to protect user process data in multi-user, multitasking environments. Process isolation is a logical control that tries to prevent one process from interfering with another. Hardware segmentation takes a step further by mapping processors to specific memory locations. Virtual memory more common on user desktop systems these days. Provides virtual memories, like i.e. swap space to disk. Provides for multitasking, multiprocessing, swapping, to name a few. Swapping moves the entire process from primary memory to secondary memory, i.e. disk. Paging copies a block from primary RAM to secondary memory disk. BIOS, shouldn't need to go too much deep on that. It's EEPROM or ROM type of thing. Most of now are UEFI BIOS with security features. embedded into it for, secure boot these days. You know, can change the other security levels of the computer or do additional hardening and or turn certain features of the computer off for enhanced security. Worm media, basically like CD-ROMs, DVDs, Blu-ray. If they're not read-write, they can pretty much be written to once. Some of the old backup style laser discs that they've had before that used to hold multiple gigabytes of data before, like Blu-ray became, or beyond the capacity of DVD. Like they would used to hold 10 or 20 gigabytes of RAM, were particularly warm, marketed at like smaller, medium-sized businesses for archival, long before Blu-ray became out. Trusted platform module, encryption chip, accelerator type of deal. It's a dedicated microcontroller for secure hardware integrating cryptographic keys into devices. TPM can be used for secure random number generator, since it's more of an accelerated function. It doesn't have to run a piece of software to do it. It runs it completely on the chip itself. Symmetric encryption, asymmetric encryption, hashing algorithms, and secure storage of cryptographic keys and message digests, commonly used to ensure boot integrity. TPMs, they offer a lot of benefits for that, so it doesn't have to run on the chip as a piece of software and slow code, so speeds up certain functions for cryptography. Data execution prevention is a safety feature that Windows will use. Used to prevent viruses and other security threats that it doesn't run through. Windows now also has sandboxing capabilities, so you need to run stuff. It can try and keep some of those programs into memory sandbox locations, so a useful feature. Address space layout randomization. It's a memory protection process for OSs that guards against buffer overflow attacks by randomizing the location where the system executables are loaded into memory, i.e. Linux pretty much does this standardly now as part of a kernel compile. Kernel itself, at ring 0 or 3, it interfaces between the operating system and applications and hardware. Monolithic kernel is one statically executed kernel that runs in supervisor mode, and all the functions required by a monolithic kernel are precompiled in. Linux is typically a microkernel, but under certain circumstances you can compile it as a monolithic kernel, especially for like embedded hardware. You can compile in just exactly what you need and nothing further. The reference monitor is a core function in the kernel. It handles all access between subjects and objects. It is always on and cannot be bypassed. And Unix file permissions, typically an octal, read, write, execute, owner and group or world level. Those attributes can be extended usually with the FACL tool. You need to grant additional users or groups access to those objects. You can extend them with the ACL attribute. But the default level is pretty much, the default permissions are going to be pretty much manipulated with the change mode tool. But you can set whether it's execute permission is on, such as a script. But like if you have root owns a script, you can make it to where the script is readable and writable by root, whether it's executable by anyone else not part of any system groups, or if it's world readable. But usually read and execute is the least permissions that most users need for a script. In some cases, if you don't want them to read the script, because it's proprietary, you can just mark it as executable only to like the world level. So it executes as a program, but then the users can't like view the source code to it. Windows NTFS, there's, read, write, execute, modify, full control, read, write, execute, and change permissions. It basically is a discretionary access control type of file system. Multiple groups can be granted access to the object, and multiple contexts can be added to it. As far as which groups get read, write, execute, and or otherwise, like the administrator group, can have, full control besides just the owner. So very granular permissions there. Virtualization and distributed computing. Virtualizing poses a whole new set of standards and practices for security concerns. With virtualization, we now have many servers, clients, on the same hardware platform host. Virtualization is software running under the OS above the hardware ring 1. Traffic between the clients and the host does not have to traverse the network. Common virtualization software, VMware, Hyper-V, Xen. With distributed computing, we could use either multiple or local remote clients for most of our needs. Most commonly, cloud computing. How do we ensure that data center meets our security posture? How do we segment their network? Virtualization costs less, much easier to stand up new servers, don't need to buy new hardware. Mean time to do it is easily. Disaster recovery, number of solutions for snapshotting and or other third-party tools that can do it, as far as making server builds or images and archiving those off for faster recovery. Usually with like virtualization, if you have like say different site offices, you can also do like replication between your virtualized data centers. So basically you can have off-site synchronized backups. Thin clients to replace standard computers in your offices. I mean, some places that want to have restricted access will do it. As far as like my fiance has a bring your own work device type deal, since she can work from home 2 days a week. So it's basically a thin client over Citrix that she gets to, and basically, she authenticates for the web browser, and it's basically a, Windows 10 desktop.
Awesome. Yeah, I didn't want to interrupt you, Mike. Sorry, I was just asking the question. I didn't know if Thomas may have some input there. Um, I know the military has tried to go to thin clients and use virtual desktops. It's an absolute nightmare. The machines are 1/3 the speed they probably need to be just to keep up. But I didn't know if you guys had dealt with it in the rest of the world. I'm trying to see what else, things I
Yeah,
need to understand more of.
like if it's set up properly, like Windows Server, like 2019 and 2022, if you have enough resources, I mean, it also depends